Okay, today uh, I am going to talk on the list data structures. So last session we discussed about the basic, what is the data structure, why this is so important for the Python programmer, and so the continuing of the Python data structures. Today we are going to just explore the list data structures, and we are going to understand the syntax semantics and how we can use the list. And we can also look the simple example how we are write the algorithms where the list help us to meet our objectives. So as we know, the list is the one of, you can say, most commonly used the data structure. So in a Python, you can say list is the frequently, or you can say in the every application somehow, directly or indirectly, we are using this data structure. So why use this list data structures? The list allow us to store a collections of item in a single variable. So here list help us. We have a collections of items, elements where we want to do some uh, processing, manipulation, transformation. So list help us. So list, you can use the list in the place where you are going to work on the collections of elements, data, you can say, right? So here, what is the list? The question first. Surely we are going to use the list. So list is an order collection. List is an order collection, mutable or changeable collections of item. That means whenever you are going to work on the collections of elements, so list is maintaining your order. So this is the order collection, you can say, and this collection mutable. That means whatever the elements you are storing here, that you can modify, you can change. List can contain element of the different types. So whenever you are going to define the list, you have to uh, define the types, data types, you can say the types of element, maybe integer, maybe string, maybe float, maybe even any others complex object even. So list is can work on the any data types which Python support, right? So for example here, here we can say we are creating the list that have an integer number, that have a string, that have a float. So list or a collections can be different data types. So simple, let's how you can create the list. So if in a Python, creating collection as a list is very simple. You can create list using just a square bracket or the list constructor. So generally you can create list using the square bracket or the constructor. Okay. So for example here, so here simply say array or list, my list and equal to, you can say this. So this is the way you can create the list, and this is the list, but this list is not contain any elements. Okay. And another way you can say, use the my list one, you can use the list as a constructor. So these are the two way where you can create the list. So here mention you can using the square bracket or you can use the list. So list is the constructor and here you can specify the initial value. Here the initial value might be you can initialize the initial value. So here maybe once you create it, if you print my list, you are not getting any value. Okay, but later part if you want, hey, I want to put some value, you can append the value and even you can say this is the value, right? So this is the way, or whenever you are going to create the list with the initial value, here you can provide some initial value, maybe 22, these some numbers you can specify, or even here you can also specify some number if you want, right? This is the way. Okay, and here you can also. So this is the way you can create the list with the initialized value. Here using the square bracket, here using the list, and you can initialize the value. Okay, so this is the two different way you can create the list in the Python. Okay, similarly, you can create the fruits. Okay, and here fruits are created, and just fruits. Yeah. This is the way you can verify the fruits are created. Okay. So this is the two different way using the square bracket, using the list constructor, you can create the list. So second item, how accessing the list element. That means if you want to get the specific element. So using index to access the element. Index is starting from 0. Okay. So here you can say I want to access print fruits one position. By default, in this list also look like array. Here, all the elements are assigned a unique index. This is the 0 index. This is the 1 index. This is the 2 index. If you want to access this value, you have to specify here index. If you want to this value, using this index, that this unique number known as a index, same as a your array concept, right? So in whenever you want to access element, you can use this square bracket and the index, which index element you want to get. And notice you can if you say something like -1. So what do you mean by here? Here equal to last element. Whenever you say minus, that means they are giving you the last element. If you say okay, this is the last element. So whenever you say 0, it is the first element. So in the Python, whenever you say the 0, that is the first element, 1, that is the second element. If you say -1, that means this is the, if you say -1, -2, notice this. So here you can see in the Python, indexing can be positive and can be negative, but generally we are using the positive one. But in the Python, you can get access element from the both indexing. One is the positive indexing 0, 1, 2. Here -1, -2, -3. So this is the two index, negative index, your negative index, and here would be your positive index. So if you want to access whatever you are interested, you Python support, you can access the elements from the positive index or negative index, right? Yeah. What's this? Similarly, okay, this is the way you can access the element using the index. This is your minus negative this one, this one, this one. This is the 0, 1 to the same. So we sometime other programming language not support the negative index, but Python support both positive index as well as the negative index. Negative index, that means -1, start from your end element. Sometime let us you want to change the list element, because the lists are mutable collection, that means you can change their content. Okay, so let us you want to change, hey, I want to change this apple or banana some different value. So here you can say, hey, I want to fruits index at one position, I want to give this different value. If you again print here, so index at the one will be going change. So index at the one previously was the banana, now it's become a kiwi. So if you want to change or modify your list, list can be mutable, that means list can be changeable. Okay. Similarly, you can add the element in the list. Let's you created the list. You created the list initially some couple of value. Later part you want here add more element. One thing, you can modify the existing one. Even you can add the new element. For adding new elements in this list, we have a couple of options. Append is the one that add at the end. Second, insert. Insert add at a specific index. Means you are say, I am going to add the first position, second position, third position. Index you can specify. Second one, expand. Expand means add the multiple elements, not the single element. There are three uh, methods available on the list where you can add elements. So let's look. So here, let's fruits dot append. Append. Here you can append one element. So appends are going to end at the last. Notice at the last. Even you have option fruits dot insert. I want to insert at a 0 position, 1 position. Next I want to 1 position. Okay. I want to index 1 position, go to the queue. And if you check at the 1 position, previously was the apple, now it's become a key. Even you can append not the just only one element or only one element at a time, but at a time you can add the multiple elements. So that is the like fruits dot expand extends, and here say I want to extend couple of elements. Okay, couple of elements. You make the iterable. So whenever this extend, you provide any iterable means any collection. Here you want to make this open and close um, um, bracket so that it's become a iterable. And now this is again one more collection. The extend pass couple of more, and if notice it will again appended everything. So sometime whenever you want to add elements in the list, you have these three approaches available: appending at the end, inserting at the specific index new value, this is the new value, this is the new value, or you can add the collections of items or elements, not one, maybe two, three, four, any collections you can use. Here is your, here these are the three approaches we are look. So like append at the end, insert at the specific position, extend is the your iterable item. So here you can any collection you can pass set, you can pass list, you can pass different any collections you can pass here. Uh, okay. So let's sometime you want to maybe removing some elements from this uh, elements from the list. So remove also we have a couple of options. Just remove by the value. You mention this value I want to remove. Or pop is the matter. Just remove by the index. By default they are removing from the last. Delete, delete and specify the by syntax. Clear, just empty the list. So let's look. Uh, so here let us we are saying hey uh, I want to removes kiwi here. Notice here we have a kiwi and after that we print. So notice this is the removed kiwi. So please aware whenever you pass remove kiwi and they have first place and the last middle. The first one they are going to remove the first found elements. If this is a multiple times, they are not removing all. Be aware. This is the only first occurrence they are going to remove. Okay. If you remove again this two times, then they remove again. Okay. Then first remove this, then next remove this. This is the way you can remove. Okay. And here even the you are going to use simple method like fruits dot pop. Pop by default specify index, or you can just say something, nothing, and just print here. It will say going to remove the last elements. What is the last element? Grabs. Grabs going to remove. Just specify particular index to the second position data would be second position data here. The 0, 1, 2, orange is removed from it. So pop take the index, whatever the index is passing from here, or if you not specify index, that means they are going to remove the last, whatever the last element it is going to remove. Okay. So let us, these are the different approach. Maybe you can apply the delete by index. One more approach we have here. Instead of pop, you can say fruits dot tail and fruits. Here is the options. You can also say, hey, delete keyword and fruits zero elements. You can specify these elements are removed. Or the two elements are the removed. Okay, 0, 1, 2, that's are removed. So del keyword also you just specify which elements they are going to remove from this list. Even you want to just clear the completely all the elements. So say, hey, fruits uh, dot clear. Clear means they are removing every element from the list. So now list become a blank. So whenever you want to remove everything, you can just say clear. By index specify, they are remove the just last one, remove by the value. Whenever you say remove by value, here remove by value, first occurrence they are going to remove. And if you want to accessing every element one by one, that is come through the looping. The looping help us. Let's say we have a list of elements. I want to first element do some processing, then next element do some processing, then next element do processing. So for those scenario we are using the syntax of a looping syntax. Looping syntax, this is the for keyword, and this is the collections. From the collections get the first value and do processing, next value do processing, next. So this is the way loops help. So this syntax is very simple. First you have a collections. Here this is your collections, this is your collections, and then this is the in keyword and the elements, whatever the elements you have, whatever the elements, this element is the your element, this is your element, and for is the just make a looping, and this element come in the body, and here you have a do process. The first element go to this variable, this variable you receive in the printing, do something, then next element go here, again processing, again third element go here, next processing, after that no element, the loop is the ended. So this is the way you can get every element and do some processing. So here say for, and here say print, and maybe you want to uppercase, lowercase, anything you want to perform. So you are getting one by element and converting to the uppercase and comma, lowercase. So whatever the processing you want, you can do. This is the uppercase, lowercase, and camel case. So lots of processing. Every element you want, you can you can do. Sometime you want to know the elements, the number of elements in the, if notice here I want to know the element must be, but notice this is a 3 or maybe some extended, this is come from some variable. So sometime you want to know what is the my length of my uh, numbers of elements in this list. So for those scenario you can use the built-in function length and pass the fruits, they give us the length. This is the 6. That means this list contains the 6 elements. Okay. So sometime you want to perform searching. Let us, we have a list contains the data, but I want to check a particular element. This element is exist here or not, or found or not. Maybe before do sometime operation I want to perform some searching. So list provide you can support, how to support using the condition. Let us here say let's us I want if let's kiwi in this kiwi in this fruits. So this is a collection, and just provide here if this is found, this is true, else. So in this way, you can say check my fruits and found. In this way, else if anything you can found. This is the way you can perform the search. Kiwi in the list. Yes, the kiwi in the list. Okay. Else mango. Maybe here say kiwi underscore. No, this is not found. Then go to the check. This is exist or not. Mango in the list. So in this way, you can use this condition this in this list, and in this way you can find or this else kiwi not. Okay. So in this way you can say particular search element found or not. Okay. Maybe anything. Let's grape. Grapes found or not. Okay, so this is the way you can use the in keyword also used to find the searching element. If you are in the for loop getting one by element, here you can just make a searching the particular search element found in this list or not. So list have a couple of methods you can say, but we are not going to talk each and everything, but some are very commonly useful. Maybe you want to sort the list. Okay, so you can say, hey, I want to uh, fruits dot sort, and after that you can print. So the fruits are sorted on the basis of your alphabet art. These are useful. Sometime you want to display, so you don't do just list have a provides this method. You want to maybe reverse. Okay, so here say, hey, I want to fruits dot reverse. So here, if you check, they are say this is the reverse art. Okay, and even you want to count the occurrence. You want to a specific elements the number of times in this. Okay, so let us I want to count print fruits dot count and check the occurrence of count the particular element how many number of times. So this is the one time. Let's check the kiwi. Okay, so it is a one time. So let's again repeat something. Let's I repeat one. Let's repeat kiwi. And if you notice, they have a two times. So particular elements, number of element in this list, you can figure out using the count. And index just find the particular get the index of an item. Sometime you want to know the index. What is the index of this key? So you can say, hey, here say index. So here, if you pass get index, they get the index of key. Index at the 0, 1, 2 position is the key. If you want to index of mango, you can say index of mango is the first 0, 1 position. You want to apple, the index of your apple is at the 6 places. So sometimes you want to know the index. Yeah, you want to find the element, find the occurrence of the particular element, sorting, reversing, lots of very useful methods available. These are the very limited methods, but you can get very huge list. Just go to the library and figure out all the library. Maybe just simply say index or count. These all are methods: copy, clear, the list type, append, clear, copy, count, extend, index, insert, pop, remove, reverse, sorting. All these functions you can very useful. You can get. Okay. Let's talk about the list comprehension. What is this? So this is the another way you can say. Generally, we discussed list can be created using this square bracket or using this list constructor. But now you can also create list in the Python using the list comprehension. What is this list comprehension? List comprehension, the concise and elegant way to create lists. So another way you can create list, not this just the two-way. Okay, so it's allowed to generate the new list by applying an expression to each item in iterable, maybe list, range, sort. So you are going to create the list and every element uh, with some calculation, some expression done, and this is come from the iterable. Let's we have a one already some collection. From this collection I want to build another list with some condition. If condition match or some expression, something, maybe some filtering. So lots of options, means run a time from the existing collection you are building another list. Many applications these are used. So we should aware list is not just created from the square bracket and list constructor, but with the apply some expression on the existing collections, yeah, iterable as well as. So what the syntax? Syntax is you are going to create this list. So first you need one kind of for your iterable, and here say from this iterable item you are getting this item, and for this item you are creating your uh, apply expression. You what the item you want, maybe same time, to uppercase, and from this iterable you apply some condition. If this condition maintain condition true, then those elements go here, and from this element you are apply some transformation, some filtering, and you can make a collection. So here expression what to do with each element. Whenever you want to make here a collection, you want whatever element you want to multiply by 2. So if element you from this element you get one element, let's say element 2, but you want to make a list with a multiple of 2, just multiply by 2. So this is your expression, something expression you mentioned. Item just represent the element which come from the iterable. Iterables in the sequence can be list, can be range, can be any collection. And the condition is the optional. If you want to apply some condition on the basis only this condition true, then those elements pop up out, then it also apply. But these are the very concise or elegant way to create list from the existing iterable collection. For example, here we have a range of 5. So range 5 means just we have a 1 0 1 2 2 3 4. This is the range. So here you can say first element ux, and here say x power of 2, x power of 2 0. Again you take one element and apply power of 2 1. Again you do 2 power of 2 4. Again take a 3 power of 9. So in this way you can, this is a create another list from this list comprehension. So let us example. So here say, hey, I want to double it equal to I want to double it bracket. Here we have a whatever the element I want multiply by, let's do, okay, uh, for for from where this range 1 to, let's say 5. So from 1 to 0 to 5 you take element, whatever the element you are just multiply by 2, and now this is the double it list created. If you want to check the type, you can also find out this is the list. So they it will create list created here. So this is the way you can syntax your expression for, and this is the element from where you get it. Any permutation combination you can even do. If you want to apply some condition here, so let us this is the another. I want to some condition here, so you can apply some condition. So let us example. So let's you want to filter the even. So here in our case, previously you are creating only from this. Maybe I can apply some condition here. Okay, let us. So hey, I want number if if element, whatever the element you are getting here, this element modulo 2, if this condition true, then get elements and multiply by 2. Okay, so let's simply, you are getting only those elements are an even number and multiply by 2. So this is the double of even number. So you can get from here only you are getting those elements which are follow this condition. If this is the optional condition, this is optional condition you can do. So here your expression element come from this list, and here condition if you want. Okay. Someone would say, hey, I want to all the odd number. So simply say, hey, print odd number. Odd number, you can say make expression whatever the elements for element in the range 1 to 100, and you can say e modulo 2 not equal to 0 and print the odd number. So let's range just say 1 to 50. Okay, and you can just get all the odd number. You want to even number, just get turn. Lots of concise way you can create the list with the help of list comprehension. And sometime again you want to perform any kind of conversions or transformations here, like this is the your words and this is your collections. You get one words and say two uppercase, so all are converted to the two uppercase. So any kind of expression here, any kind of transformations also perform in this list comprehension. Okay. So let us sometime even you can use if else inside expression as well as. So like here with condition if else, like here say uh, if this modulo true, then even, else odd if this come. So here you can say whatever the element x come here, here you can apply if and condition. Okay, so let's, so here say whatever the condition here. So let's if this is the condition, let's just remove here. Okay, and here you are getting the elements. Okay, so here just number. Okay, this is the no. No. Okay, this is sorry. This is this simple now. Okay, so here let's say this is just like that. Okay, so here this is the 1 2 3 4. I want to condition here. I want to not just print here, even from here you can apply some condition. Okay, so here you can say this for here in this this is the complete things, there is no. Okay, so here whatever the here you can apply some condition here. Say if uh, print even if e modulo 2 double equal to 0, else you can out. So here you can write the condition. Whatever the element you receiving here, if this is modulo true, this, if condition true, else this. This is the way you can you can uh, you can do it. So this is the way sometime you want to apply condition here, you can do it. And most probably this lots of permutation combination here you can do, right? So let us talk. These are lots of permutation combination you can do, but list expression comprehension also is another way you can do. So this is the list. Do using this list, we can do lots of our application. So sometime you want to perform action that's are not in build. So list provide lots of your built-in function, but sometime this function may be not fulfill your requirement. Then you can create your own algorithms. Means your own set of step you're going to define. So here data structure help us. Data structures and algorithm. Algorithms step-by-step procedure to perform a specific task. So lots of whatever the list, yeah, array, all the data structure which Python provided, they are for the common for the every application. But some application, a specific requirement, you can build your algorithms on these data structure. So let us example. We are going to create an algorithm to find the lowest elements in the list. So generally, if you create the list, my list, my list, okay, here are some number, maybe 20, comma 2, comma 12, something number, okay. So here you want to find the lowest element. So generally, if you talk, my element are lowest. So there is no such find lowest, okay, find lowest something. So here you can write your some steps. So next question, how we can find the minimum element? The first you are going to think, hey, this is the my list, and list have a couple of element. I want to find the lowest element in this list. So you have to perform. Let's assume you iterate one by one, take the first elements. Let's consider your the minimum element is the first one. Let's assume this is the first element minimum. Go to the next element. Next element is the 12. 12 and which is the minimum? 12 minimum. You can just change here. 12 is the minimum, not the. Go to the next element 34. 34. 34 is the lowest? No. 56? No. So 11? Yes, 11. In this step by steps, you're going to find out which are the, if 11 is the LMS, so change it, this is the 11 is the lowest. Go to this 23, no element. 25, no. 67, no. 89, so. So in this way, you write the steps to find out this is the lowest element is the 11. So for that, you can write some function, you can write your algorithm. So here, instead of that, you can write, hey, let us, I am going to write my function. So here say, hey, let's define find lowest element, okay? Element. So what the approach we say, let's take first variable min, okay? Min value. So first, to take the whatever the list we have, list of first. Let's assume the first element is the lowest, and after that I'm going to make a loop for uh, for every element, take the elements and check if your element, whatever the element you're taking, less than mean value, then you can say mean value is the new mean value. And here, and just return, this is the return your mean value. So what we did here, we just written my own algorithms. We will get the first element, and after that we go to check every element. If the other elements, any element is less than, then assign this minimum value. Now notice this is my function prepare. Now I can go, hey, let us call print find lowest element and pass by list element here. So now our API say, hey, return this is the lowest. Maybe you want to just say 5 and again run. You can say 5 is the lowest. So sometime you can build your own algorithms. Here we have written my own algorithms. Algorithm is a sequence of steps. First, I get the first element as the minimum. I loop every element, and I'm going to check every element is less than my minimum value. So I can change my minimum value if something is less. And once we have come our looping, finally we found the minimum value. This is known as a data structures algorithms. We written my own algorithms. Algorithm nothing, just set of specific steps. If they set up a specific step perform, we solve the specific problem. Here we are trying to solve the specific problem, finding out the lowest value in the input list. Whatever the input list, some want to find the maximum or minimum or sum or every lots of permutation combination the problem can. So here we can find the minimum value, right? So a couple of way you can think, but the basic building blocks of the list are already provided by our Python, and apart from that, in my use case, we can write my own algorithms. Here, like they are finding the first element at the minimum. They are looping the input array and finding any value is less than my minimum value, so my minimum value will change. And finally, once your loop is done, finally we return the minimum value. And you can just, if this is the my array, you can pass my function, and this function find lowest value, return the minimum value. So in this a specific point I want to convey here, you can build your own algorithm on the top of existing data structures like a list. So list is the most commonly used data structures in Pythons, and whenever you are going to generally build any application, list directly or indirectly always used. On the top of this list, you can write your own algorithm to solve your customer or specific problem if the existing library not provide. So today we have covered the basics about the list, basically the number of way you can create list using the square bracket, using the list constructor, using the list comprehension, and couple of methods. Whenever you can create the list, you can create list with the initial value. With the initial value, you also learn how to get element, access element, different approaches, and also we can learn how to add element in this list, maybe within the specific position at the end or collections of list. Even we understand how to remove element from the list, maybe from the starting, from end, from a specific position. So these are the couple of operation list by default offer, but sometime our customer our requirement not fulfilled by these list methods, then we can write my own method with the help of algorithm. The data structure support, you can write your own definition, own function on the top of existing data structure. So you can use the list functionality, and you can build your own customized logic. That is known as an algorithm. So as per the customer requirement, we can write my own algorithms if our existing data structure API or methods not available. The first our approach, we have to use the existing library, and if a library does not support these kind of operation, then we can write my own algorithm. We can define my own business logic in the form of methods, and that method can be used by the our different client, different application, different places. So hope this information is helpful for you. Uh, that is the point today I want to convey. Thank you.